Hi everybody, I'm Kathy Blaine and I'm the Director of Clinical Education for the Respiratory Care Program. We're doing a series of videos to make sure that our clinical instructors all rate our students fairly. Today I'm going to be doing a video on a high-flow nasal cannula. To begin with, I'd like to just step back and talk about BiPAP and CPAP masks. Many of our patients are on BiPAP and CPAP. Now, some of the masks that we have fit very comfortably and don't cause any pressure necrosis. So for example, if I was to take this mask and put it on an adult, all right, you could see that there would be very few areas of his skin that would be touching the mask. For example, supposing I was to take an infant also and try to put this mask on, you can see again that very few areas of the skin would be touched. So these are masks that these nasal prongs don't cause pressure necrosis. Particularly in our adult population, though, many patients favor different kinds of masks. So you are all familiar with a nasal mask like this. When we put it on the adult, if we have to strap the headgear on too tight in order to make a seal and prevent leaks, we're pressing against the patient's skin and this causes pressure necrosis. All right. If I look at another series of masks, here is what is called a scuba mask for an adult, okay? And if I put this again on the patient, okay, and I have to secure it tightly, I have more pressure necrosis. We also have a scuba mask for an infant, and you can see that particularly with an infant's delicate skin, that this would be a problem. So, in our profession, many of us are familiar with using a material like this, Mepilex, Tegaderm, Duoderm, in order to put this on the patient's skin and cause a barrier so that pressure necrosis doesn't occur. However, there is an alternative, which we are also all familiar with, and that is the high-flow nasal cannula that can be used for many patients instead of having to deal with these BiPAP, CPAP masks and cause pressure necrosis. In the next part of this presentation, I will go through in detail all the things you need to know about a high-flow nasal cannula. Hi everybody. I'm back and I've changed my clothes because I'm going out to visit some clinical sites this afternoon. What I would like to do is review with you the setup for the high-flow nasal cannula. To begin with, we have an IV bag of sterile water, and this is going to, of course, drip down into our complex humidifier. This is a great method of preventing infection for the patient because we don't have to constantly open up the circuit. Secondly, I'd like to go over here and show you that we've got high pressure hoses. I've got a green oxygen hose and I've got a yellow medical gas hose, and I would be, of course, hooking them up. This is over to my wall units here to provide the 50 psi gas that is needed. Now, if we trace these back to the blender, okay, we can see them coming in here. And the first problem we have is that our medical air hose is not hooked up. Because of this, you would expect to get an alarm from the blender if there's a greater than 5 psi difference between the air and the oxygen, and it would sort of sound like this. So anyway, you would correct that situation because you know you'd made a mistake, and the gas would then go into the blender, which is a high flow device, and it is designed to give anywhere between 21 and 100% oxygen, and that is really important depending on how well or how poorly your patient is doing. After the gas has been blended, all right, the flow comes outside here, and then it can go to one of two types of flow meters. All right, either a regular flow meter up to about 15 liters per minute, which would be for smaller patients, or I could actually put a high flow meter on here, which could go up to 40 liters per minute for an adult patient. Once I have my flow set on my patient, I then have a small bore tubing which goes down, okay, into my pressure pop-off here. This is an important device because in case the patient is lying on any of this tubing and pressure builds up, it will be relieved here and the patient will not get a face full of hot humidified gas. So the dry gas passes through and it goes here into my complex humidifier. The complex humidifier is designed to produce 100% body humidity, in other words, 100% humidity at 37 degrees. Once the gas has been humidified, it then goes out here onto my inspiratory line. Now at this place we have several devices which are designed to help the high flow nasal cannula be efficient. The first device is, okay, let me turn this, is right here. This is the proximal probe of the servo loop, and here is the distal probe. This is a feedback loop that constantly adjusts the temperature so we can get it as close to body humidity at 37 degrees centigrade as possible. So that's one wiring. The second set of wiring goes in the back here of the inspiratory side, and this is hooked up to something like this, a pigtail, which goes in here, and this heats the wires which are insulated and inside the circuit. We know that heated wires are designed to prevent rainout, okay, so that we don't have water sloshing back and forth in the tubing, which would then decrease the flow to the patient. So we have a servo loop and we have the heated wires. Finally, up here at the patient, we have an appropriate size device. This is an adult nasal cannula which can be put on the patient easily, and the patient can eat and drink while wearing this. Now, if I step over here a minute and pick up, this circuit is for an infant, or a slightly larger one could be for a pediatric patient. And you can see I've got pretty much the same setup. I've got a proximal, and I've got, oops, excuse me, a distal probe, all right? And this again is for the servo loop. I've still got an attachment back here for my heated wires to prevent rainout. And then the only difference is really up here at the patient, we have different size cannulas. We have 3 sizes, one for preemies, one for neonates, and one for peds. And those, we can choose the appropriate size for the patient. Now, just as a quick review, the blender is likely to alarm when there is a greater than 5 psi difference between the air and the oxygen pressure. We know we have a pressure pop-off in the circuit to relieve pressure so it doesn't harm the patient. We know that a modified passover humidifier, which is at body temperature, can produce aerosol particles, okay? And we know that heating is important because aerosol particles are very likely to pick up bacteria which can be delivered to the patient. All right. We know the heated wires prevent rainout, and we know that the servo control allows us to maintain body temperature. At the end of this presentation, there will be a quiz that you take, and I think I've covered all the questions on the quiz. I'd like to thank everybody for being here, and particularly the people at CCP who filmed me, and I hope you all have a good day.